Well, welcome back, guys. Some of you know me, some of you don't, I believe. But essentially, what I'm going to do for the course is I'm going to create short introductory videos for every topic. If you watch them prior to attending your class, then that'll give Mr. Lewis a little more freedom in sort of flipping the classroom so that you do more work and discussion then. There'll be hopefully about 10 minutes each topic, and you'll have, I guess, 2 to 4 probably per week. If you watch this, I will post these at about the same time each week that I post the assignments, which are called tests just because that's the way I know to create it. It's not a test, it's homework. So if you access the video and that my little assessment, my little homework at the same time, then that's probably the best way to get you thinking about it. Watching a video is maybe not so engaging, but if you kind of pause it and go back and forth and make attempts at the problems. You get 3 attempts per homework, so you can go through it the first time with the video and not really lose anything. So the first video is about rational expressions, and you know what a ratio is. A ratio is division, so it's a fraction. An expression in math, if you know what an equation is, an equation has to have an equal sign, but an expression can be anything. It doesn't have to, well, it definitely doesn't have an equal sign. So if I write, say, 4x squared minus 3 equals 7x plus 1, this is an expression and this is an expression, and when I put in the equal sign, this becomes an equation. So normally you think of a ratio as something like 3/5, but if I write 4x squared minus 3 over 7x plus 1, that's still a ratio. So now it's a rational expression because it's a ratio of expressions. So that's what rational expressions mean. It means a fraction where the top and the bottom are some sort of mathematical expression that may or may not just be a number. This is still a rational expression, but so is this. So that's what it means. So the first thing that you want to be sure of is that your denominator isn't 0. Whenever you have a denominator, you want it to not be 0. So if I write something like 6 over 2, the reason this is equal to 3 is because this is a question. The question is, if I have 6, how many 2's do I have? And the answer is I have 3 2's if I have 6. This answers the same question, it's just that if I have 3, how many 5's do I have? I have 3/5 of 1, right? But also, if I have 6, how many 10's do I have? You have 3/5 of a 10. So this always answers that question. So if I end up with 0 on the bottom, then the question is, if I have 4, how many nothings do I have? Well, I may think you don't have any nothings. 4 doesn't mean anything with regard to that. Someone else could say you have infinitely many nothings. Someone else could say you have 12. However many nothings you have nothing, you don't have 4. So this is a nonsense question. So that's why you can't divide by 0. So if I go back to having a rational expression, say 3 over x plus 7, this doesn't look like 0, but sometimes it is 0. So I need to say when this is not 0, I need this to not be 0. So in this case, x is not -7. So you can kind of create a domain, right? You can say, well, this is all well and good except for here. So any x is okay, so long as that x is not -7. So that's how you check the domain. And if you had, say, 5x over x squared minus 9, you could just say x squared isn't 9 and then take the square root, but you might forget the -3. So this kind of safe thing to do is factor it, because you need every factor to not be 0. If any factor is 0, then it's 0. So you factor it first. So you need this not to be 0, and you need this not to be 0. So x is not 3, and x is not negative 3. If you're not sure how I got any of this, stop and go try to work it before you continue with the video. Anytime you feel like you're not sure what's happening, go and try. Right now, I'm going a little fast because technically this is review. So hopefully this is okay. And if you have any questions, if this isn't review somehow, then just someone send me an email and I'll make another video. Okay, so there's the domain. Now, what if you had, say, 3x plus 9 over x squared minus 9? Well, you want to factor the top and the bottom. As soon as you realize it's factorable, you should factor things. It's just always a good idea. So I can cancel this, but I didn't just change the domain. Because the fact is I still had x squared minus 9 in the denominator. It was still there. X still can't be negative 3. So I still have this domain, x, so that x is not plus or minus 3. But everywhere except these two places, it reduces to 3 over x minus 3, which brings us then to reducing. So when you had, in the past, you might have had something like 4 over 12, and you wanted to reduce this. And so you break it down to its prime factors, and then you cross out anything that's common, so then you end up with 1/3. It's the same thing with a rational expression, it's just that the prime factors are the irreducible factors. They're often numbers or lines. Sometimes you have a quadratic that can't reduce, like x squared plus 9. This can't be factored. But you factor it down as much as you can, and then you cancel out like terms. So if I have this one, which we already showed before, then I want to write this as 3 over x minus 3, if you note what we did just a moment ago. This is what we ended up with. So this is reduced. Once I have them reduced, I can get common denominators just like I did before. So if you had, say, 4 over 12 plus 6 over 9, you'd first reduce that one to 1/3, and then that one to 2/3, because this is 2 times 3 over 3 times 3. And then you get 3/3. And then that's 3 times 1 over 3 times 1, that's 1. So you just keep reducing all the time. But once you get this, your fraction's totally reduced, then you can get a common denominator. So if I'd had instead 4 over 12 plus 5 over 9, say, this doesn't reduce. So first I reduce this one, and I would have already factored that, 3 times 3. So I say, okay, well I have 2 3's over there, I only have 1 over there, so I need to add 1 on top and bottom here to get a common denominator. So now I have 3 over 9, 5 over 9, makes 8 over 9. So we have a similar circumstance with the rational. We have, say, 3x plus 9 over x squared minus 9. I'm just doing this to save time on the factoring for the purpose of the video. So let's say this is x squared minus 4x plus 1. I'll just make that easy, make that 5. Okay, so we can reduce that, first of all. Now that's in simplest terms. This one needs to be factored. Oh, sorry, I meant to, it should have been 3. So we need two things that multiply together to give 3 and add together to give -4. So we have 1 and 3, minus 1 and minus 3. These are our only options, so x minus 1, x minus 3. This again should be a review. If it's not, let me know and I'll do a video over this. Okay, so we both have a x minus 3. So this one then needs an x minus 1. So this is distributing 3x minus 3 so 3x minus 3 plus 5. And if you want, you can turn it back into that, or you can leave it factored. It really is up to you. You need to be able to go back and forth between them. Your exams, I'll grade your work, but your exams will be multiple choice to start with, and so are your homeworks. So you need to be able to recognize if this is the answer or if that denominator has been switched back. You need to know they're the same thing, that's all. There's one other thing with these is being able to multiply and divide and then simplify. So remember with fractions, you multiply just straight across. So if I have 3x over x squared minus 9 times x plus 3 over x squared, for example, I would simplify them first. So 3x, x minus 3, x plus 3, x plus 3 up here, x, and then mark out the ones you can. Remember that you didn't just change the domain restriction. You still can't have x equal to negative 3. So I think all I have in the top here is 3, and here I have x times x minus 3, which might look like, by distribution. So that's multiplication. You might also have a fraction, you might have it divided, and it might be written like this. Might be like this, or it might be like this. So these are the same, of course. In either case, you invert and multiply. So from here, you'd flip that upside down and put it next to this one. Here, you just flip it upside down. It's already next to it. So this is 3x like this. That kind of lost control of some of that, but we know that's a 3 there. Now I'm going to simplify. So 3x, x minus 3, x plus 3 times. And up here I have x minus 3, x minus 1, 6, x. Oh, sorry, this should have been 2 times 3. So 3. So what I have left on the top is x minus 1. Down here I have 2, x squared, and x plus 3. So I might distribute or I might not. Kind of depends on your end goal, but when you're matching multiple choice, you just need to be able to go either way. That is it for rational expressions. If you have any questions, send me an email,